We are on page 212, right? And we already looked at one special way of factoring. We're going to look at the second way. So we're going to talk about products, which means the answers to multiplication problems. I'm going to multiply, and then I'm going to break a multiplication, I'm going to break an addition problem into multiplication. So that's why it's two parts. And this is the general format right here. This is the general format. Now, does this remind you a little bit about about perfect square trinomials?
Yes.
Is that at all this is kind of what we did? But it's not a perfect square trinomial because what am I dealing with right here? It's not a trinomial. It's a binomial. So it's not a trinomial. So let me ask you this. Should we try out our bridge method to factor? No. Should we try out perfect square trinomials method? No. Should we try out where you just write the two binomials and then you just pick what are two numbers that get me the third that add up to be the second? No, it's not going to work. But there is an easy way to figure these out. And I want you to realize that these problems are called, and you need to write this down, the difference of two squares. The difference of two squares. And that's a plural there. The difference of two squares. So I want us to look at that expression, see, does the name really fit it? Okay, why do you think we call this a difference? Because you're subtracting right there. And then I say the difference of two squares. Who can explain that to me? Two squares. Two terms that are squared. That's why we call it the difference of two squares. So I hope that's not beyond our capability. There's a way to factor those, and there's a way to multiply them a lot easier. So let's look at the first problem. Okay, write this one down. 5m plus 6n times 5m minus 6n. Now that I look at it a little bit closer, doesn't it kind of look like a perfect square trinomial problem? It does to me. But it's not, because there's one big difference.
The signs.
What about the signs?
One's positive and one's negative.
One has an addition problem, one has a subtraction problem. So that should automatically tell you don't use perfect square trinomials. Okay, I want you to FOIL that. Go ahead and FOIL it, please. So you need practice FOILing, and this is another way to do it. But from here on out, hopefully you can know the shortcut and on these problems not have to FOIL, because something happens.
Oh, I know, Mr. Yeah.
Okay, what do the first terms get me when I multiply them? 25m squared. What about the outer terms?
30.
Yes?
Negative 30.
Negative 30mn. Murphy, what do the inner terms multiply to get me?
30m.
Positive 30mn. And you could say mn or 30nm. It's the same thing. And then what do the last terms, Betsy, multiply to get me?
Negative 36 squared.
Negative 36n squared. Okay, great. And then I have two like terms. And what happens to those like terms? They get canceled out because they are opposites. Now, do you remember perfect square trinomials? We also had the same O and I terms, but what happened? We had to take them and then multiply by 2. Does that happen on this problem? Nope. So we're left with 25n squared minus 36n squared. That is my final answer for multiplying those two together. Is there a shortcut on this?
Yes.
Someone give it to me. Explain it to me. I want it. Davis.
Okay, so what you do is that you just times, you square 5, say times 5 times 5 equals 25m squared. Then you times both 6 and negative 6.
Okay, so here, can I simplify that? You're saying it right. Why don't you just do F and why don't you just do L? So what's F times what are the F terms together?
25.
25m squared. What about the L terms? I don't know what I said. Okay, so I get my 36n squared. But why do I not worry about O and I? Because O and I are always going to be opposites. And what happens when you add opposites together? They cancel each other out. So that's my final answer. Great. Let's try it again. I want you to multiply this out. And if you know the shortcut, please do it. If you don't know the shortcut, even on the test, what can you do? FOIL. And then simplify if possible. And then you get your answer. C plus 14 times C minus 14. All right, so I'm looking at this one. And John, what's my answer?
C squared minus 28.
Not 28. You're close.
Oh, yeah, it's okay. My bad.
What's 14 squared?
Negative 196.
196. Now, listen carefully. Shh. How many of you knew 14 times 14 is 196? Anybody? Okay. How do you know it? You've even so, you just memorized. You just remember. Yep. How do you remember? You practice math facts, but you eventually get to it. If you didn't, this is what you should have done, and you would have gotten 196. Okay, so that would be your answer on that one. Okay. Wait. Is that a difference?
Yeah.
Is that a square? Is that a square? So I have how many squares? So we call this a difference of two squares. That's my answer. That's why we call it a difference of two squares. Okay, that's too easy. Let's move on. Next, this would be on page 213 in your books. It's it's that. Wait, make sure. Yeah, I hope. Yes. Wait, why did they put that? Okay, good luck. That's all I could say. Caroline, did you get the product?
Yep.
Okay, what'd you get? D to the second, sorry?
C to the second minus 1.
Minus 1. Oh. Okay, but what about those negatives?
They cancel each other out. Wait, what do you mean?
Yeah, okay. Two negatives multiply to get me a positive, yeah. And so, yeah, canceling out means they eliminate each other, but here you get negative d times negative d is just d squared. And then negative 1 times positive 1. That's my answer. And this is a difference of two squares. This right here is a difference of two squares. Okay. How many of you can identify?
How is that a difference of two squares?
Oh, that?
How would negative 1
No.
be a square? Because if you're multiplying negative 1 times 1, and those are two different numbers.
Uh-oh. Follow me, Swivel.
Wait, what?
This is a side bubble. Michael just took us not into reality, but into the imaginary zone. Negative 1. You're saying negative 1, Michael. And you're right. The square root of negative 1, what is that?
It's 1.
No. 1 times 1 is positive 1. Negative 1 times negative 1 is positive 1. So what times itself gives me negative 1?
1 to the negative square power.
It's I.
Semicolon.
Imaginary.
I. It's an imaginary number. The value of I is defined by the square root of negative 1. Now you're like, wait, what? Okay, I don't know that number.
I see what you did there.
I don't. Yes, that's exactly. Yes. I wish I had this first class so I could have pretended like the second class I knew what I was doing. But anyway, I didn't even go through this in the second class. Sorry, the first class. Because you guys brought it up. But Michael, you brought us to the imaginary zone. This is the dreamland. And the square root of negative 1 is I. And you're going to deal with I a lot next
Year.
No, 2 years from now. Okay, you're done with that. That's my imagination. Next. Okay, but Michael, that still didn't answer my question. Isn't that I then? No. Is this a difference? Yes, this is a difference. That means it's subtraction. And the difference is of this and that. So what's the square root of d? Squared, excuse me. What's the square root of d squared? D. What's the square root of 1? 1. And so now you can come up with, if you're factoring, plus 1, minus 1. So you're not getting the square root of negative 1 like you did in perfect square trinomials. It's just a binomial, difference of two squares. It's a difference. There's a difference. Okay. It's not my fault. I just say stuff and I speak in puns.
Okay, when you have c squared minus 196.
196. So you do c, the square root of c squared. It's not. We're not even done. We're halfway done. The square root of c squared is c, and the square root of 196 is 14. And you do plus that and minus that.
Okay, so they don't always have to have like an x bonus.
Oh no, they don't. They can. They can, or they, as long as you can get the square root of that, it works. All right. What if I didn't give you a multiplication problem, and I asked you a very important question, and I've been asking you this for a long time in this chapter. It's a key word. What have I been asking you in the instruction? Factor. So if I tell you to factor this, what do I want you to do with it? Make it into a multiplication problem. It is not multiplication right now. So identify, is that a trinomial? No. So we're not doing the bridge, we're not doing the two binomials, we're not doing perfect square trinomial. We're going to go with the difference of two squares. And is it really a difference of two squares? Well, let me see. Can you get the square root of that?
Yes.
What would it be? X. So that's a yes. It's almost like the perfect square trinomial method. Can you get the square root of 225?
Yes.
What is it? You memorize it's 15. Okay, but what are my two factors? So it's x plus 15 and x minus 15. That would be the binomial factoring of that binomial. You're like, wait, two binomials multiplied together give me a binomial? When there's a difference of squares, yes. So easy. Not yet.
The difference of squares and then like you square root it. So like x plus 15 and x minus 15, you're just doing a different sign. So
Yes. Yeah, one's positive, one's negative. But I need to ask this question here. You know what, Matt? I like saving space and I like saving paper. Okay? So I want to rewrite my answer like this. Oh, no. Oh, sorry, time out. Matt, I meant that. You guys are super picky because they're the same thing. Why is that not right? Because why? No, that's not why. Tell me.
Because negative 15 squared would not give you negative 225. It would give you positive.
Anything doubled, you cannot make it a negative.
Okay, here's why. Can I tell you why? I'm going to erase that. If I wrote x plus 15 squared, doesn't that mean x plus 15 times x plus 15? Or if I write x minus 15 squared, does that mean x minus 15 times x minus 15? Is that what I'm saying here? No, because they have different signs. So don't simplify it by making it wrong. Okay, you guys are so good at this. Take it. You may begin. Oh, sorry. Oh, wow. Oops. Yep, that's a fraction.
Oh, wow. Yeah.
Ouch. Murphy, give me the answer.
You said you're done.
One or 10.
Close.
Yes, 1/2. There's actually not. It's 1.
Shh. John.
Don't you just,
Rachel. Go ahead, give it.
Am I doing it?
Yep.
Okay. Do that. 1/2 n plus 13. And then 1/2 n minus 13. Why'd you say that?
Okay, listen carefully. What is the square root of 1/4 n squared? Well, what times itself is going to get me 1/4? 1/2. So it's 1/2 n times 1/2 n, 1/4 n squared. What times itself is going to get me 169? 13. So you plus and you minus it. That would be your factoring right there. It's the difference of two squares. But you can't have a fraction without a decimal. Actually, you can't.
Pretty sure you can.
No, honestly, you can't. Because fractions and decimals are the
Same.
they're part of the same thing. So that's why you always talk about them together, especially in the older grades, because they're just there.
They're always there.
Yeah. That 1/4 and that what was it? Oh, just the 1/4. It's actually right here. You guys see it?
Yeah, I see it.
Where?
It's 0.25.
Yes, 0.25 is a fourth. So got to do the same thing except with decimals. Sorry. Okay, like moving the decimal twice? Good question. If you multiplied both of these by 100, you could, but you know what you just did? You made the problem 100 times bigger. So the only time that works is when you have like equals something, where you do to one side, you do to the other. You don't change anything, but you can't do it on this. So good question. Got to keep decimals, and the decimal answers have to match. This way? Wait, oh, that's that.
On 16 is like 4.
Yes, but then you have to think about where's the decimal point go.
Okay.
Yeah, but it is 16. Yeah, you got it? Oh,
Any way you can simplify that or no? Like the
Like-
answer? Like write it out?
the answer. No, like the last one maybe? Like this one?
Yeah, like there's
Nope.
no way you can.
No, because if I remember that one I wanted to try where you just 1/2 n plus 13 squared, but they're not the same. If they were, like perfect square trinomials, yes, but this one's a little bit longer. You have the answer? Okay, yes. First of all, what's the square root of 0.16 x squared?
It's 0.4x.
0.4x, not 0.04. Because what's 0.04 times 0.04? It's still 16 with a couple extra zeros. And that's not what I wanted. So it's 0.4x. Okay, square root of that, 0.25y squared.
It's 0.5y.
0.5y. And I'll make these decimal points. Same thing. It's not 0.05. It's 0.5. And then how do I finish this answer off? Wyatt. This is not my full answer, so how do I get it?
Plus.
Plus sign? All right, got that.
And then the same thing again, but minus.
Yep, same thing, minus. All right, I have a question. I get the same problem. I wrote this correctly, but I did this. Nice. Right or wrong?
Oh,
Because
no,
it would
it's wrong.
have to be a negative 0.5 and then a positive.
That's not right.
Right or wrong?
Right.
That's right.
That's right.
Yes. Do you notice the first term is going to be positive? The second term is going to be positive or negative. And you're like, what do you mean second or first term? First term, second term. Yes, sir?
Never mind.
Okay, that's all right.
It'll take you
That
longer.
wasn't serious. You can ask me.
No, it can still take.
Hey, what are you trying to say? Swivel. Oh, okay. You get YouTube videos, right? You can play at faster speeds. In fact, I wouldn't listen to myself at this speed. I would listen to myself at this speed because it goes quicker and I can still process it. So double speed.
You know, it'd be funny if we watched the video right now and like.
Oh, then do that. Double. So quadruple that.
You should be live.
So basically,
right now
yeah.
on Twitch.
Yeah, because you already.
That's later, okay?
That's very.
That's when I make it big. Okay, write this poem down.
It's the rate of the church.
What?
Like, okay, that's pretty random. 106 times 94. All right, this part, I want you to multiply this out mentally, not with paper, no work. So this is in your... Oh, you can.
I know, I hate that.
How do you even line?
Sorry, try it out. Do your best if you can kind of straighten things out, but...
I'm already lost.
That's okay. I am too. I can't do that, by the way, like in my head.
And then I lose. Oh.
Okay, this is what we're going to do. I know it's kind of hard. If I gave you enough time, maybe you can figure it out, but it is tough. Let's make it easier. Okay, 106 times 94. No. But what we're going to do is I'm not going to look at it as 106. I'm going to look at it as 100 plus 6.
2098.
No.
Or you have to
Again.
go again.
Okay, you get... No. How many of you are okay with saying 106 is 100 plus 6? Fine.
Sure.
And then 94 is not just 94. It's 100 minus 6. No, that doesn't do me any good. All right, difference of two squares. So what's 100 times 100? And this, I would say you could just... It's 10,000.
164.
It's 10,000. And then what's 6 times 6? 36. And what do we do with those two?
Wait,
I can't even.
9.
It's
6.
9,900. It's 64. That's what I just said. I said that like 3 times in a row. I'm working on that.
Mental. I said do it mentally.
I was so close.
I was so close.
How about let's do this. Let's do one more, and then I'll let you go. Let's do 18. 18 times 22. Go ahead and do that. 18 times 22 mentally.
They still say the answer.
It can be. You can break it apart, factor it, and then those two factors can be written. So you're manipulating numbers, but yeah, you know what? Can I tell you this? It's harder to see because it's arithmetic. Algebra is easier to see. Algebra is easier than arithmetic. Conclusion. Oh, yes, sir.
I got it.
I don't know. Go ahead.
No, I got 196.
Okay, let's test it. So what's 18? It's 20 minus 2. What's 22? 20 plus 2. And you're like, instead of doing the 4 multiplications you have to do, you're only going to do 2 of them. That's in essence what you have to do. You know, normally when you do this, you would do a number. You're doing 4 times. Now you're only doing 2. What's 20 times 20?
400.
What's 2 times 2?
Minus 4.
400 minus 4?
396.
I don't know if you said that, but that's correct.
That took me a second. That took me 100.
Okay. Thankfully, I'm only going to make you do that on the test. So, oh wait, shouldn't say that loud. No, you don't have to do that. It's just something that you can
You
use.
could just write it down and then erase it and just get that.
We don't have to do it.
So I'll look at Sarah's paper to make sure nothing was erased. Okay, go ahead and start this homework out. The first section, you just multiply. You can use a shortcut or FOIL. The second section is where you have to take that difference of two squares and factor into the two binomials. So you have 2 parts.
Wait, what?
Oh my. Goodbye, Swivel. I'm glad you had to see the rest of this.